Good morning, everyone. Today we will see method of solving recurrence equation. That is recurrence tree method. There are so many methods available for solving recurrence relation. One of the method is called recurrence tree method. It's a visual representation of recurrence relations. And recurrence relation represents the time complexity or time taken by the algorithm in a mathematical equation. So by solving mathematical equation recurrence relations, we can find the time complexity of algorithm using recurrence tree method. Recurrence relations of time. Recurrence relations represents the time taken by the algorithm with respect to input size n. That is, relation is represented in the form of terms, multiple sequence of terms with respect to n. Recurrence equation that explores the time complexity t of n in terms of t of n by b or n minus 1 in terms of n. It helps to analyze how algorithm runtime scales with input size. When the input size increases, what will be the change in the execution time or T of n? T represents the time complexity or time taken by the algorithm to produce the result, where n is number of inputs called input size. So the recurrence equation contains two variables, time and input size n. Here, the expression equation represented in the form of n, terms in n. Recurrence tree is a tool for analyzing time complexity of recursive algorithm. It's mainly used for analyzing recursive algorithm. It's a visual approach for solving recurrence relations. By drawing tree, we can analyze the algorithm and we can find out total amount of time taken by the algorithm. It is mainly applicable for divide and conquer algorithms. It helps determine the time complexity of an algorithm by breaking down the recurrence into a three structures and analyzing the cost at each level. Recurrence relation is converted into recurrence tree. Tree contains multiple levels. We are finding cost at each level and find the total cost by adding up all the values at each level. How the recurrence tree method works? There are 5 steps. First one, uh, recurrence relation is given and output is recurrence tree. So construct the recurrence tree. Begin with the given recurrence relation. Draw a tree where each node represents the cost or the work or the time taken by the algorithm to complete the particular step. Here the problem is divided into number of sub-problems. Root is a whole problem. Again, if it is divided into two sub-problems, it has two branch in the tree. So it is applicable for divide and conquer approach based algorithms. And second step is calculate the cost at each level. For every level in the tree, determine the following. The number of subproblem nodes at each level, the cost taken by the each node, multiply with the total cost at all the levels. That is calculating the cost at each level. And third step is determine the height of the tree. So how many levels are there? So root next immediate children is level 1, level 0. So finding the number of levels or the height of the tree that can be used for finding the total cost of the given recurrence relations. After calculating cost at each level, add the cost of all levels to get the cost of overall algorithm of recurrence relations and express the cost in asymptotic notations. After solving the recurrence relation, find the time complexity or big order of big O notations, or by applying any asymptotic notations, we can find the upper bound, that is maximum amount of time taken by the algorithm. There is order of growth or time complexity for the given recurrence relations. So these are the important steps in recurrence tree method. That is, recurrence relation is converted to recurrence tree. Tree contains multiple levels The node value represents the cost. So find the cost at each level and add the cost of all levels to get the total cost of overall reconciliation or overall the tree. After solving the equations, find the order of growth. Example, solve the recurrence relation T of n is equal to 2T of n by 2 plus n using the recurrence tree method. This is an example for MedSat. MedSat, the problem is divided into two subproblems. That is 2T of n by 2. Each problem having the size of n by 2 inputs. Initially, n number of inputs divided into two problems with equal number of inputs. That is n by 2, n by 2 plus n. N represents when we merge two subproblems, n by 2, n by 2 subproblems, algorithm performs maximum n number of basic operations. In the case of MedSat, for merging two sorted array, it performs maximum n comparisons in the worst case. So this is the recurrence relations for MedSat. 2T of n is equal to 2T of n by 2 plus n. Now we are going to draw a recurrence tree. So root node represents n, number of inputs. This level 0. And the next level, the problem is divided into two subproblems with size n by 2, n by 2. For example, initially 50 inputs. The problem is divided into two subproblems. Each subproblem has 25 inputs, n by 2, n by 2. Next level, again, that each problem is divided into two subproblems, that is n by 4, n by 4. There are 4 n by 4. That is level 2. So this process is repeated until we have a single element, that is 0 or one element in the array. So this is called developing recurrence tree for the given recurrence equations. The node represents the cost, and so we have to find the number of levels. So that is logged in levels. We know n, the relations n by 2 power k equal to 1. So k is number of iterations. Number of iterations represents the number of levels in a recurrence tree. That is log n iterations or log n level of the height of the tree is log n. So now we are going to find the cost for each level and multiply the cost per level into log n to get the cost for overall tree. So we will see step by step. First step, level 0 root node. That is n is number of nodes in number of elements in root t of n equal to 2t of n by 2 plus n. So at the level 0, the cost is n. And level 1. So next level 2t of n by 4. Again the problem n by 2 is divided into two subproblems, that is 2t of n by 4. So at that level we have four subproblems with size n by 4 inputs. That level the cost is n. So the number of input is same, the total cost will be same. And calculate the cost at each level. Every level cost is n. For example, see the table. Level 0, number of nodes 1, cost per node is n, total cost is n. The next level, we have two subproblem with n by 2 size. So the total cost will be n. Again, that is divided into four subproblems, n by 4. So these process is repeated. This division process is repeated till we have a single element. So how many elements? So there are n inputs. We have n number of single element in the solution space. So number of comparisons will be maximum n. So at each level, that cost will be n. So now we know the cost at each level. So now next we will find the height of the tree. So how many levels are there? So n by 2 power k. So n is input. Every iteration, the problem is divided into 2 half. So k number of iterations till becomes 1. Number of inputs become 1. So that is the relation n by 2 power k. So take log both sides, log n and log 2 base 2 power k. So bring k front side. So log 2 base 2 value is 1. So now the k value is log n. That is number of iteration is log n. So we have root node. So the height of the tree will be log n plus 1. So k is the height of the recursion tree, that is log n iterations Each iteration is one level plus 1 is for root node. So height of the tree will be log n base 2 plus 1. Now we know the height of the tree and we know the cost at each level. If we multiply these two things, we can get total cost of the recursion tree. So sum the cost at all levels. Each level cost is n. Then there are log n plus 1 levels. So T of n is equal to n plus n. That is the cost at each level. We are adding all the levels. So no total number of levels will be log n plus 1, including root node. Each level cost is n. So n into log n. So when we find the big O or order of growth, when we apply asymptotic notations, we are taking the maximum term with n. So here we have n log n plus n. So n log n value is greater than n value. So the time complexity of the given equation will be order of n log n. That is the time complexity of MedSat by applying divine conqueror approach. Cost calculations and cost at each level. This is a general diagram. So T of n is a root node. The problem is divided into two subproblems, n minus 1 and n minus 1 and 1 n minus 2. So each level the problem is divided into two or many number of problems, three subproblems. So we are finding the cost. C represents cost at each level, C, 2C, 4C, and find out the cost for each level. There are number of levels will be 2i, 2i. So if we add all the cost of different levels, we can get the cost of overall recursion tree. So the conclusion is the recursion tree method converts the recurrence relations into a tree whose node represents the cost at each level. If we find the cost at each level, we can multiply the cost with the height of the subtree, height of the recursion tree. So we know height is log n plus 1. So we multiply height with cost at each level, we can find the total cost or total execution time taken by the algorithm. So then we sum all the per level cost to determine the total cost of all levels of the recursion. So by adding cost at each level, we can get the cost of overall recursion tree. Thank you.